Finally, for chapter 4, we finish off with the trapezoid. We define a trapezoid. Trapezoid is it's not a parallelogram, it is a quadrilateral with exactly, and this exactly is important, exactly 2 parallel opposite sides. So we're pretty familiar with what it might look like. Notice that these 2 sides are not parallel yet. These 2 sides will be parallel. So that's what it might look like. We say that the 2 parallel sides are the bases of a trapezoid. So this is a base and this is a base. The 2 non-parallel sides are called legs. So this is a leg and this is a leg. The median of a trapezoid is a line segment joining the midpoints of each leg. So let's look at an example here. Let me draw a different kind of trapezoid. Notice that we don't always have to have it look like this. It might look something like this. A little bit different than maybe what we're accustomed to. But again, this is a base and this is a base because these are the 2 parallel sides. This is the leg and this is the leg. And the median is a line segment joining the midpoints of each leg. So let's look at the midpoint of this leg and the midpoint of this leg. Join these 2, and this is called the median. We also have a specific kind of trapezoid. In fact, both of these are this kind. If 2 legs of a trapezoid are congruent, well, let's think about a triangle. What do we call a triangle if 2 sides of a triangle were congruent? We called it an isosceles triangle. Well, we call it the same thing. If 2 legs of a trapezoid are congruent, then it is called an isosceles trapezoid. Just by inspection, it looks like maybe both of these are isosceles trapezoids. Here's an example of a non-isosceles trapezoid. So let's have a couple of parallel sides, and then we could have something like this. This guy goes over here, and maybe this guy goes way out here. Again, this is a base, this is a base. Running out of room. We'll say that this line segment is parallel to this one. So these are my legs, and it's pretty immediate that these legs are not congruent to each other, so this is an example of a non-isosceles trapezoid. So we can have things that look like this, we might be accustomed to thinking of things like this stuff. A couple more facts and then some theorems about trapezoids. Every trapezoid has two pairs of interior angles which are supplementary. And we'll look at an example. We'll do a non-isosceles trapezoid. So we can say that this is 1, 2, 3, and 4. So we notice angle 1 and angle 2 are supplementary. And we know this because these lines are parallel, and two parallel lines cut by the transversal, which in this case is this leg, the interior angles will be supplementary. Likewise, angle 3 and angle 4 are supplementary. So there's a pair that's supplementary, and there's a pair. So every trapezoid has two pairs. And it's the pairs that are on each. One pair for each leg. Theorem. Base angles of a trapezoid are congruent. I'm not going to prove these. I'm just going to list them. You can use them for your homework. You can read the proofs in your book. And then we're finishing up, we'll do one example. So another theorem about trapezoids. Diagonals of an isosceles trapezoid are congruent. And finally, we have a theorem about the median. And this is a theorem that you might use to solve a problem. The length of the median of a trapezoid, well, it's the average of the lengths of the bases. And here we're going to start connecting an algebraic idea of taking an average of two things. And we can view this algebraic idea geometrically. And that's exactly what we're doing when we look at the median of a trapezoid. So the average of the length of the bases, that is the median Now another word, the median of the trapezoid is equal to, the average of the length of the bases. So how do I calculate the average? I add up the bases, so base 1 plus base 2, so I'm going to add up both the bases, and then I'm taking the average of this, so how many things am I adding up? I'm adding up two things, so I'm dividing it by 2, or in other words, I'm multiplying it by a half. So it's equal to 1/2 of 1/2 times the first base plus the second base. Let's look at an example problem for that theorem. Suppose we're given trapezoid R, S, T, and V. Doesn't have to be an isosceles trapezoid. Let me just be clear that this is a base. This is a base. This is R, S, T, and V. M and N are midpoints of, now these have to be midpoints of the legs. Okay, that's what a median does, connects the midpoints of the legs. So it's the midpoint of line segment RV and S line segment ST, again, respectively. So M is the midpoint of RV, so there's my M. N is the midpoint of ST, so there's my N. These are midpoints. So we have the median is the line segment MN. So if I draw that line segment there. Now let's use that theorem. Suppose RS, the measure of RS, is equal to 12, and VT, the measure of VT, is equal to 18. What is the measure of the median line segment MN? Well, from the theorem, we know that the median, the measure of the median, notice I'm saying the measure of because I'm not writing line segments, I'm talking about the length of MN. It's going to be 1/2 times the length of the first base, which is RS, plus the length of the second base, which is VT. So this is going to be 1/2 times 12 plus 18, which is 1/2 times, what is that, 30, which is half of 30 is 15. You might use that last theorem to do a problem like this.